Welcome, everyone, and thank you for joining today's webcast that is about continuous engineering with pure variance. I am Shivani Hegde, and I will be your moderator. And I'm happy to introduce to you Dr. Yang Lee from Pure Systems, who will be our presenter for today. Dr. Yang Lee works as a field application engineer and consultant where he shares his knowledge about product line engineering and pure variants in tutorials, trainings, and workshops to help customers on their journey towards a systematic variant management approach. Before we start, I would like to show you all that you can find all the upcoming webcasts on our website. All the webcasts are recorded and uploaded to the Pure Systems YouTube channel. Should you have any questions, you can post them anytime in the chat system. Only our webcast team will be able to see your questions, and we will collect all your questions and answer them in a Q&A session that is at the end of the webcast. If there are any open questions left after the Q&A session, we will contact you after the webcast to follow up. With this, now I would like to hand it over to Jan.
Okay, thank you, Shivani, and welcome everyone from my side. So in this webinar, I would like to introduce you to Pure Variance capability of being integrated into your continuous engineering. Okay, let's get started. So before we have a look at an overview of continuous engineering, let's think about a development workflow. When developing products, lots of organizational tasks and development activities are involved. Many of them are tedious, but happen many times daily. For example, when a new change is introduced into your source code, you have to review whether the new source code snippet satisfies your code standard or not. If there is a problem, the developers should be notified, fix this issue, and then request a review again. If there is no problem, it can be merged into the master and then do further steps like compile, test, deploy. Yeah. So you can see if you have lots of changes every day and if anything goes wrong in the workflow and you manually do all the steps, it consumes you lots of time on this tedious organizational tasks. So continuous engineering is meant to automate these tasks and activities as much as possible to enable a seamless process of development. Let's start with the developer to see how continuous engineering works in general. With configuration management, the source code can be managed properly. Yeah? So developers can use source control management and version control system tools like Git and SVN to have code repositories, commit changes, and trigger pull requests to the master branch. And when a new pull request is created, the review process can be triggered automatically to check the changes. And you can integrate code review tools into your Git or SVN to track the discussions on the changes. Moreover, if you want, a static code analysis can be run automatically for the source code changes by some tools such as check style before a manual review. If there is a problem, the developers will get notification automatically to fix it. Otherwise, you can have a manual review to decide whether it's okay to merge the changes or it should go back to the developers for further fixes. Let's say if a new merge occurs, and we go to the continuous integration to see the corresponding activities. And you have tools here like Ant and Maven to automate the building steps with scripts, and your codes will be also compiled. And if you want, you can also trigger an automatic analysis for your binaries. If everything is okay, it automatically goes ahead to trigger the unit testing and integration testing, and finally, store the artifacts such as gfrog, artifactory, or container images. But if something was wrong found during this testing, it would also give the feedback and notify the developers to fix it. Okay, if this part is done, you have a new build without problems. We move on to the continuous delivery. In this phase, you deploy your artifacts into a staging or testing environment automatically. And once the artifacts are deployed successfully, you can run acceptance testing. If everything is accepted, it is available to be deployed to the production. But you need a final approval to do that, which of course is a manual decision. If there is an error or testing failed, the developers will get the feedback also. If there's no error and it is proved to deploy it to the production, then we go to the continuous development phase and deploy the artifacts to the production automatically. So during the whole workflow, if there is any error reported, the development team will get notified to fix the issues. While you might use different tools for different activities like version control, code review, build, code analysis, testing, deployment, and so on, and integrate these tools into your continuous engineering with Jenkins or Circle CI. Well, pure variants can also be integrated with your existing continuous engineering to automate your PLE related activities as much as possible. Then let's go to the next page. So pure variants comes with an integrated end support to easily integrate variant management actions into your build processes. Your CI/CD engineers will be surely involved into this integrating activities, while product engineers and variant configurators also need to decide which PLE-related parts they are responsible for should be automated. Pure variants provides many end tasks. Let's see if you want to trigger a transformation via end build file. What end tasks do you need? Of course, firstly, we need to create a new build file. We go to the context menu and go to new and create a new file. Here we give the name as build .xml and then finish. This is an empty build file. I will simply copy paste the existing scripts to here. So in this file, you can see, of course, the project name, automotive demo car light, and also we have this transform, which is a default target we want to run. So you can see in this target, it's actually you have different pure variants related tasks. So here we have this pv.import task. So this task is used to import, of course, your variant project into this workspace. So if this project is already in this workspace, then nothing happens. Otherwise, it will import. And below there, we have this pv.transform. This is just a task to trigger a transformation. Here we need to give some define the name of this transformation, also the VDMs. So I will go ahead to play this video. You can see the name is actually the transformation, which transformation you want to trigger. So this is configured in your configuration space. You just need to give the name here, like I want to trigger the export DOS transformation for this variant. This is the VDM. This is the variant model you define in this configuration space. Of course, you can also trigger multiple transformations if you want. Here, I also have two of them. I want to trigger the transformation, this one for the VDM high beam adjustment and also no high beam adjustment. And the last task is just a task to refresh your local resources in this project, because we want to load the newly generated artifacts or files immediately. Then we want to refresh this project. Okay, then let's have a look at how we can run this build file inside in this Eclipse client. Before we do this, we also need to configure something. For example, we need to configure the Java runtime, the runtime GRE. To do that, we need to go to the second part. You can see this end build with this ... Let's go ahead. Okay. So the first part you can see is the target. This is default target transform. We define here, but actually in this script we just have one target. you can have multiple targets, it is no problem. Then you can decide here which target you want to run. Yeah. So here we just have only one, then we run this one. Yeah. Now I want to switch to the GRE. If I want to run the scripts, I have to switch to the first one, run this script, this build file script in the same GRE as the workspace. So this part must be done. Okay. And then after that, we can apply and then run this build file. You can see in this console, we have some output information. Yeah, this pure variance import task is triggered, and also we are doing something for the transformation, and now it's done. The build is successfully done. Okay, so this is how you can trigger how you can trigger transformation, how you can run your build file inside in this Eclipse. So here, this example is for the transformation. I also would like to show another example to how you can run the PV unit test via these end tasks. So PV unit test is used to check whether the configurations of your variant models are expected or not. If you are interested in this topic in pure PV unit test, we also have a video on Pure Systems YouTube channel for this topic. So let's go ahead. In this script, you can see it's quite similar, right? We also have this project name, automotive demo car lines. Yeah, but this time the default target is PV unit testing. In this target, we have some tasks like, of course, I want to import this project into this workspace. And then below that is pure variance, PV unit test, this task. So the first keyword is the GUnit result. This one is just used to specify the path of the result file. And the test path here is used to define which test case should be run. The first one you can see, I just point to the folder here, holding these 3 test cases, meaning that I can just point to the folder and then run this PV unit test task. Then all these test cases can be run. But in addition, here we have additional keywords here like this tag and value. So I will play this video. You can see here, we have the test cases 1 under this folder, test case 1, with this tag and value, Eclipse, and value is 3.8.2, meaning that I only want to run the test cases in this folder with the tag as Eclipse and value as 3.8.2. So it's kind of a functionality you can just match the tag and value to decide which test cases you want to run. Okay. And then let's have a look at the next one, this test path here. So, but the second one, you can say I just directly point to the concrete test case. You can also do it in this way. This test case 4, this one, meaning that I want to run this test case via this end scripts. Okay, now let's say I want to run this build file, but this time I have already configured this runtime GRE. So I don't need to configure it again. I directly select this first one. I just want to run this build file. Okay, I click this one. Also, in this console, we have some output information like this task is triggered and starting the test cases, run the test cases, and it's done here. And here we also have, you can see the output file in this .xml file format here. It's named GUnit, but this file, the name can be changed if you want. So here you can see in this result file, it holds the how many of these test cases the failed ones, or how many of them passed, and you get some information about errors. But in this test cases, all of them are passed. So this is the result file holding the all this PV unit test cases results. Oh, sorry, then I switch to here. Oh, what happens? Okay, I stop here. And this is the, you can see .xml file, But actually, you can reuse this file. For example, you want to generate an HTML file to show this the result is no problem. Yeah, it can just reuse this file and to display all the result in the HTML. It is possible. Then you can have a better overview of all this result. Okay, then let's go ahead. So in previous example, we showed the build files with only one target, yeah. But you can also have multiple targets in the build file. Okay, so in this example, you can see, yeah, we separate this different pyramid tasks and tasks into different targets. Yeah, we have the target all, import, PV unit testing, transform, and refresh different targets here. Yeah, you can see the default target is all, and all depends all these following targets, meaning that if you want to run this build file, all the targets will be run automatically because this is default, all is default, and all depends all the following targets. But you can also decide, yeah, when you run this scripts, you can decide which target you really want to perform, yeah, when running this build file. It is also doable. Yeah. Okay, then we have seen how a build file can be run inside PureVM's Eclipse client. And now let's have a look at how you can run the build files without manually starting the PureVM's client. So the first part you can see this is a command, yeah, can be used to directly start the nscript runner of Eclipse with the nscript build file. Yeah, this is a command and this is a build file. Yeah. And also the path here to an existing or temporary Eclipse workspace. Yeah. And also you can see we have this valid PureVM license, yeah, defined here in the last part. So this is a command for the yeah, Eclipse console application. To simplify this, PureVM comes with two batch files or two shell files, yeah, located in the CLI subdirectory of the PureVM installation directory. So this run and batch file, or yeah, it's if you are using Windows, it's batch file. If you are using the Linux or Mac, of course, it's the shell file. Yeah. So this run and starts the given end build file with the internal Eclipse and runner, and we have another one variant CLI. So for this script, it can start the given transformation configuration on all provided VDMs here. So if you are using Linux, of course, yeah, we also have the corresponding shell scripts here. And here, this is a screenshot to show you where you find these two files. For example, this is the installation directory of pure variants. You go to maybe the default is a CDisk, yeah, and then program files, pure systems, pure variants enterprise 5.0, and then you go to the folder CLI. You can find these batch files. Okay, then let's go to the next one. Yeah, so we saw how to run the build files inside Eclipse. Yeah, now let's see how we run it in a headless mode. So here, what I'm showing is also this build file with multiple targets. Yeah, we saw this one earlier, right? And now I want to run it in a headless mode. Okay, let's go ahead. So on this part, you can see on the left-hand side, this one, this is the command prompt that is used to execute the batch file in this example, because I'm using a Windows system. And here, on the top of the right-hand side, it shows the two files provided in this CLI subdirectory. And below here, it's just the variant project folder holding the build file. Okay, then let's go ahead. Now I can directly drag and drop this batch file to the command prompt and give a space here. And then I drag and drop this build file to here because I want to run this build file via this script. Now I hit enter. So you can see here, just because I didn't specify a workspace. So we will use a temporary workspace. and then it's starting this pure variance tasks like import project to this temporary workspace, and then it's starting this PV unit testing. Everything's fine. Then it triggers this transformation for different variants. Like we have this no high beam adjustment and also high beam adjustment. And now it's done. So this is a very simple example. You can use this. You can use this. You can see batch files to trigger a transformation or to run your build file in headless mode. So in this way, you can see by trigger this transformation in headless mode, or by trigger this PV unit testing in headless mode, meaning that you can easily integrate this kind of activities into your continuous engineering by using this pure variance on tasks in headless mode. Okay, then let's go ahead. Yeah, so we have seen the pure variance and tasks and how to trigger them in headless mode. It would be more interesting to show you a demo of how pure variance can be integrated into your continuous engineering workflow. So you might use different solutions to realize continuous engineering, but here we just want to use this Gitlab as an example to show you the capability. Okay, let's go ahead. So we have seen this overview in the beginning. Actually, many tools can be used to realize continuous engineering and build up your CI/CD pipelines. Well, GitLab and GitHub are usually the platforms used for configuration management, but they also support for a CI/CD. For example, the developers can use GitLab's CI/CD or GitHub Actions to create CI/CD pipelines that can directly interact with your configuration management. For example, the events from your repositories like pull requests or merge requests can trigger your CI/CD tasks. In our previous webcast, we have shown how pure variance can work with GitHub for the configuration management. So in this webcast, I would like to switch to GitLab to show a demo with pure variance build actions. Let's go ahead to have a look at the demo. Okay. So you can say here, we have a remote repository holding this and transformation example, and we will use project here in this repository to show how transformation can be integrated into GitLab CI/CD. In this project, you can see we have some folders here. Also, we have some files. This the XML file. This XFM file. They're actually the feature models now. And then we have another file. Of course, this is a build file. Let's go inside to have a look at what kind of end tasks do we have here. So actually, it's quite similar. We have this project example, and we have this default target transform. And in this target, we have some end tasks like import, like this refresh task. And also we have the transform task. But in the end, you can see, there's another keyword, continue on error. But this one is false, meaning that the task will throw the build exceptions if there is an error. But if this one is set to true, this here is set to true, the task will finish successfully but logs problems if there is an error. Okay. Of course, there's another task. It's named pv.evaluate. This task is just used to evaluate your VDMs. Also, you can use this keyword here to switch on whether you want to continue or not. Okay. Now let's switch back to have a look at another file. This one. So this is the GitLab CI yum file. This is a file where you're you configure specific instructions for the GitLab CI/CD. Let's go inside into this file. Okay, so you can see here we have multiple keywords like the image, status, build, and deploy. So for this part, first part, actually, we have a pure variance Docker image used to run all the CI/CD jobs. And we also have two stages here like build and deploy. And in the build phase, actually, there is a very simple or very short script to show a piece of information like, okay, this job runs after the pyraminx Eclipse client Docker image has been successfully built. Just a very short example. Yeah. But in this deploy phase, yeah, you can see we have already defined the variable VDM holding all the variant models we earlier defined in your configuration space. For example, the E car and also city car, the super sport car. So they are the variant models. The name is the variant models because we want to trigger the transformation for all these variant models. And then let's go to the script. You can see here, yeah, we have the command here, like this is a run ends shell file because we want to execute this build file, the build script file in a Linux system. So we need to go for the shell file. But the thing is that, yeah, this one is not default one. Yeah, this run end file is not default one. It's actually customized by us. So here, you can see you can use the default one. You can also, yeah, customize this file by some other user case. Yeah, or I mean for some other user case. And this last part is the VDM here. Yeah, this is a variable, and we want to trigger transformation for all these variant models. Okay. So here in the last part, yes, we use this demo Docker tag to select the runner. And also we have the keyword for the artifacts. This is path, the output path, holding the output artifacts. Okay. Now let's say I want to add another variant model to this YAML file and perform transformation for it. Because it's based on your workflow. Maybe you have a new product developed and you want to include this new product variant into this YAML file. Yeah, you want to add something new here. So we can directly edit this YAML file. Here I just, create a new line and then give the name of this variant, the new variant model. And here I just give a short message. Yeah, I want to, I edited a new variant model and commit the changes. Okay. And then let's go back to here. You can see after I make some changes and commit changes, there is a new pipeline here created and it's running automatically. Yeah, so it's triggered by this event, right? Now, if I go inside into this pipeline, you can see we have this build stage, and also we have this deploy stage. If I click this deploy, you can see some job is running here. Yeah. Okay. And then I can also switch to the another tab here to show all the jobs. So you can see here for the build, yeah, it's passed, but some other jobs for the transformation. Sorry, it's too quick. Yeah. Some other jobs for the transformation is still running. Yeah. Okay. Then let's have a look at the concrete job for this build. You can see we can have a look at all this log information. Yeah, when this job is running, you get some output here, the information you want to know. Yeah, you can directly go to this part. Now let's switch to the pipeline again. Yeah, we can switch to the deploy jobs. Let's just select one of them, but you can see all of them have already passed successfully. Then let's go for the first one, city car 2. Yeah. You can also have a look at, you can see the output information. So if you remember, yeah, we also have a look at this, for example, pv.transformation information when we trigger this, or when we run this build file inside in the Eclipse, right? So this is the same thing here. We have this information. And then, of course, if you want to download your artifacts generated by this job, you can also click download here, and then you download your artifacts. So here you have some folders like we have brakes, we have something generated for the brakes, engine, gearbox, and safety. Yeah, and this is a variant. This is log for this variant. Let's just go have a look at one of this file. Yeah, so here we, oh, sorry, it's too quick. Then I will stop here. Yeah, so you can see here we just print out some features here. As I mentioned, this is just a simple example. Yeah, I just want to use this example to show you the capabilities. Yeah. So I don't want to use very complex example to make you confused. Yeah. Okay. That's it. That is regarding the demo. Let's go ahead. Here is a short summary of what we learned in this webcast. Yeah. So we know that the pure variance capability of being integrated into your continuous engineering. And this is realized by pure variance build actions. Besides we saw today, for example, the transformation and PV unit test, and of course you can have multiple targets. Yeah. So we also have many other pure variance end tasks that can be used. Okay. And yeah, the end build files can be executed in the headless mode via the Eclipse console application, or you can use the batch file or the shell file provided by pure variance. It depends on what kind of operating system you are using. Yeah? Okay, and yeah, we showed a simple demo of pure variance with with GitLab CI/CD. Yeah, but you can do the similar thing with GitHub Actions. It is no problem. Please note that not only for GitLab and GitHub, if you use other tools like Jenkins, yeah, you can also integrate pure variance to your CI/CD pipelines. Yeah. Okay, so in the end, yeah, I would like to quickly remind you where you can find all these webcast recordings in the past. They are actually on the YouTube. Yeah. So you can see here we have the Pure System YouTube channel. If you search for Pure Systems, you will find our channel with multiple playlists, and it will show you our own webcast recordings and also some recordings from our partners. Okay, so that's all for my part. Thank you for your attention, and I hand back to Shivani.
Thank you, Jan. So now we have some time left for question and answers. So I see one question. So the question goes, does Pure Variants support creating and tasks to synchronize the family models imported in full mode by a connector?
Okay, so yes, the answer is yes, of course. It is supported by Pure Variants already. Yeah. So if you would like to know more detailed information about Pure Variants and scripts, please have a look at our Pure Variants user guide. Yeah, you will get more information. Thanks. Yeah.
Okay, thank you, Jan. So I see there are no more additional questions. So with that, we will end the meeting. Thank you for participating, and hope this was very helpful for you all. And we look forward to you in our future webcasts. Thank you, everyone. Bye.
Thank you. Bye.